Good morning. At least I hope it's morning wherever you are. That's what we all hope for in life. I have returned. I've returned. I'm making a spell scroll today. I've actually already done it. I've got the whole template and everything figured out. If you're on YouTube, you can look in the description for that, and if not, I bet I can paste that into Twitch chat really quick. No. Hang on. Let me pull that up for y'all. I need to share a link, and here we go. Alright. If you need the share link for what we're doing today, it's in chat. This should be pretty straightforward, pretty simple. And I'm going to cover this to the best of my ability. So yesterday I was making spell scrolls for a bunch of spells that I couldn't show off because they're from other source books for Dungeons and Dragons. But I decided that this was cool enough, or that I thought that this was fine enough, that I would do it with some default Dungeons and Dragons spells. And I started with Fireball, and I think that's as far as I plan to go. If you want more spells, you can do that on your own. It takes quite a bit of work on my end to do that for you. So yeah, let's just start. First, you need a name. I've translated all this stuff into Latin, and I'm using a font that looks nice in Latin, which is this font. It's called Chinzel, I don't know how to pronounce it. Anyway, I think it looks fine. You could do anything you want. You could do like a runic language or cipher or something special, but I just went with Latin because my players can't read Latin at all. And the only Latin I know is from A Plague Tale, because it comes up a lot. Alright. First is the name. We're doing Fireball. Fireball. Ignis is fire. Globus is ball. Right? That goes in your scroll header. If you're looking at the template, this should already be there. You'll just replace this text with whatever your spell text is. You could just use plain old English. You could use some sort of Tolkien language or whatever you want. Under info, I've added a lot of the spell information again in Latin because they probably don't need to read this section anyway. There is another page with the actual spell info down here. You won't see that in the template because I don't want to just publish, items that are not mine at all. Right? Obviously, I don't own Fireball, so I don't want to just put that out there. But for the demonstration here on stream, I will show this off. We can look at it a little bit closer. Oh, no, the website breaks if you scroll in too much. All right, I won't do that. Yeah, I bet we can get to... Unless there's a zoom. Is there a zoom? Oh, there is. I'm just dumb. Right, so you can see Fireball. And then actually gives you an item card here. When I print these as physical pieces of paper, which I will do and I'll post to Instagram a little bit later, I print this on the back of this sheet just so they've got both of them. I think it makes things a little bit easier. Next is the scroll info. This is all of this spell information that they're going to need. Basically this whole block here. Now, not all of this block goes in there, but enough of it to get the idea. So in this case, it's just this level, level 3, evocation, 1 action, 150 feet. The components, which are verbal, somatic, and material. And then the duration, which is instantaneous for this spell. There are a few spell scrolls I have. Let me grab them, actually. From a book that just has them as magic items, so they're not tied to a spell at all. Now, in that case, I've added a little note up here in Latin and a little note down here that says that either this scroll is consumed or it isn't. For one of them, which is very special compared to the rest of these, I had to completely reformat the spell scroll to fit this on here, but it's not consumed, and you're able to draw on it. So I'm going to have to do some magic to get that to actually function. IRL. Because obviously if you draw on it, you'd have to erase it. Okay. Next is the sigil. I'll come back to the sigil in a second, because that's going to take some more explaining. Next up is the actual incantation, which is what the player will say. Part of having a spell scroll is reading it out loud, or just reading it, right? Using the actual scroll to channel the magics. So here, I've made all of these like very direct. Some of them are jokes. If I could read Latin better, maybe I'd tell you a bit more. But this one just says I said I cast Fireball. So I think literally it means I say that I like channel Fireball or something. I don't remember exactly what it means, but long short of it, this just means I said I cast Fireball as a funny joke. Now we get to the sigil. I've got a bunch of these. You can actually see in the thumbnail for the video, in the background, there is an icon. Just like a little SVG line art thing. I made that using software. So we're going into kind of a heady land here, where I tell you about code that I've produced recently. So, just a fair warning, just to be completely fair warning, this here was 100% vibe coded at like 4 in the morning. Except for a few things that I had to manually go through and fix. That were wrong, that I had to fix. At some point, I will probably rewrite all this, if it needs rewriting, and double check and add proper documentation and all this and release it, but for right now, I don't care enough, and it's not good enough. I have to go through it and manually tweak all of these values every once in a while. You can see like some hack stuff here, that I have to check if the outside shape is a triangle. I'll explain how all this works in a second. But just to run it, we've got our input string here, which in the future would be, a proper interface. For now, this is good enough for my purposes. And then I just run it using the run and debug, which is not how you're meant to do things, but again, I don't care. If it works, and it's stupid, it's not stupid. This generates a sigil. That's going to be pretty hard for you to see, actually, because it's black on black, but trust me, there is a sigil. This one is a pentagon with a hexagon inside of it, and some of the vertices are linked. That is how this whole system works. It's just one shape instead of another shape, and some of the vertices are linked. So let me tell you how we go from this string of text to this sigil here. I will do so in MS Paint, Microsoft Paint. Cool, that should be fine. Let's see, can I make the screen a little bit bigger for you? There we go. Okay. So we've got a string of letters, right? So let's say it's like A. Oh, that's a little bit off screen of what you can see. A, B, C, D, E, right? Now I need to take a string of characters that could be any length, and I need to convert it into a string that is a fixed length with specific character sets. How do I represent a fixed length string? I don't know, I'll do it like this. Yeah, there we go. I wish I had this prepped, because I can't really draw in Paint very well. To end. There we go. Right, so we convert this from a string that is of random length, of any length, to a string that is of fixed length. Fixed. And we do this through a process called hashing. Hashing converts a string through a one-way maths operation to a fixed length. It's not really a string, but you can think of it basically just a fixed set of bits, right? Or a fixed length set of bits. And you get some guarantees with hashing, specifically modern hashing, which is that you have very low collision. Collision means, can you take one string, A, B, C, D, E, and another string, cats, and if you convert them, do you get the same thing? If you do, that's a collision, and it's bad. You don't want collisions. Modern hashing usually guarantees you a different output, right? So no matter what you do, if you put a string in, it'll give you a string out that's a fixed length that is unlikely to match the output of another string that you put in. This is used in passwords quite frequently because you can't take the string. Because it's infeasible to take the string that you get out and convert it back to the original string. When you give a company your password, they make a hash of it and store that number. And then when you type your password in again, they hash it again and they check if the hash matches. That way, if anyone breaks into their database and steals your password, they can't actually get the real password. They just get the hash. That's unrelated. I'm interested in this fixed part here. Okay, then we've got a fixed length of bits, of bytes, right? A fixed length of information. I need to take the first two of those. The first two of them are very important. And I convert them to here, I believe. Yeah. So this is a function I wrote. Basically, you take a string and it converts it into another. It hashes it to a set of characters that are between the numbers either 3 and 8 or 8 and 1 in this instance, right? So it outputs a string that only consists of the digits that you set in between here. I hope that makes sense. Actually, maybe I can run it and we can actually take a look at what that means. No, let's set our point here. Okay, if I run and debug this now, we're going to see some cool info. All right, we don't need that for the timing. So this is a bit of complicated computer stuff. But we can take a look. It has stopped the code right after I ran this function. And you can see for digest, which has the characters between 8 and 3. If we take a look at just the digest, every character here should be between 8 and 3. And if I don't see that, then we've got a bug. But I do see that. For alt hash, it's going to be between 1 and 8, because this is used for a different purpose. And you see all of these numbers are between 1 and 8. The math to do that is, I'm not going to explain that. You should, if you're really interested in that stuff, you should go look at like any computer science course. There's free ones available. Okay, so what I get from this is these first two numbers. That gives me the size of the outer shape, right? If we look back here, the size of the outer shape is this digest 1, which should appear here, right? We don't want that. Or we can actually just see digest 1 is 5, because we start counting from 0. So the outer shape will have 5 sides, and the inner shape will have 6 sides, right here. And we can actually see that's correct. So we've got 5 sides on the outside. If I zoom out, the outside has 5 sides. It's a pentagon. And the inside has 6 sides. That is a hexagon, the bestagon. Let me re-up my tea really quick. Hang on. I'm needing some caffeination. All right. Then we choose a random number between these two. We find the maximum number that we could choose, right, between 1 and 8. Obviously, if these were smaller, if they were both like triangles or something, the max number would be 3. Right, so this picks a number between 3 and 8, the maximum size you could be between the inner size and the outer size. Then we add these to an output string. This is really just for my tracking, because I want to have a full string at the end of this that tells us what we're doing. So let's actually build this out in Paint really quick. Take another look at this. So we've taken in some Latin, right? This is not exact, by the way. So that is, the mix of caps and everything is gonna freak someone out. And we're now converting it to, oh, you can't even really see the L there. There's an L over here. It's not adding, it's just Latin. We've converted that to the first number that gets added is digest 0, which is 6. And then we take digest 2, which is digest 1, and that's 5. So this tells us the inner shape. Inner, and this tells us the outer shape. Outer. I misspoke earlier. I think I misspoke anyway. I said that the max of this was 8. It's 8 in the maximum case. Currently, the max size is 6. Okay. Now, close this so you can actually read. Now we want to find the first number after this 5 here. It's actually, we're going to check this string, alt hash instead. We want to find the first number that's after 5 in this string of hash, this hash string, that is less than the max size. Basically, this allows us to get a seemingly random number of connections in the final shape. So if we've got the shape here, right? In the shape here, we want to connect their vertices with lines to give us a sort of sigil. We need to decide how to do that. And if we just started, basically, if every line connected to another line, it would look very similar. All of them would. We add a little bit of variance by doing this kind of semi-random selection. It's not random. It's not random at all. It's deterministic. But it will appear random to the users. It also means that we're less likely in the final shape to have duplicates, right? So you're not very likely to have one string convert to the same sigil as another string. We want to try our best because we are shrinking down the hash to reduce collisions. Again, that's the kind of one thing I'm concerned about is don't have these collide. And with the 6 or so spells I've done this for, it's been fine. There's been no similarities. They're all very different. So I think I've hit the sweet spot here. I didn't sit down and do the math on what that sweet spot would be, but I think I guessed and got it right. Okay. So in this case, the first number that we see after our 5 here that is lower than lower than 6 is 3. It's the first one here. It's actually very likely to be this first number, just the way that math works out. But anyway. So, hang on. I'm trying to get my head wrapped around what we're doing here, because it is a little bit complicated. 3 is the number of connections that we're going to use. Right? The number of connections, we see that here. There are 1, 2, 3 lines that connect vertices. That's what we're deciding. Then, we go back through the... you know what? I think I've just found a bug. This is when we look at the code again. Anyway, we should go back through the hash, this alt hash that I have set up. And if the number is even, we add it to the output and we convert it to a number between 1 and, well, it depends. The first number here encodes the inner value, if I'm not mistaken. And the second number encodes the outer value. So basically, this tells us how we link the numbers together. But again, I think I've just found an issue. Maybe. So this is converting. Basically, we're going through, we're looping from 2, which is this number here, this 3, I can't highlight it for some reason, to the number of connections times 2, because each connection is made up of 2 values, 2 numbers. Let me zoom in a little bit so you can see a bit better. It just means that I won't be able to see. Can I make this smaller? I don't know. Where's paint at? I don't think it matters. Can I see that? Let me go back down here. My last breakpoint. Okay, jump to the next one. Okay, let's zoom out a little bit. I see. This is technically fine. So I think it's okay. It's technically okay. Which is the best kind of okay. This looks back through the digest of those values between 3 and 8. Because a triangle has 3 sides, octagon has 8 sides. And it loops through, and basically if you're even, it notes that down. It wants to truncate things so that the even values have a maximum size of the outer shape, which is 5. In this one case. For the inner shape, for the outer shape, it wants the value of the, to be capped at the number of vertices of the inner shape. Let me just show you. We're connecting these two shapes with a list of numbers. Let me actually write this down. so I can show you in paint. 6, 5, 3, 5, 4, 1, 2, 5. That's the final number all written out. On our sigil here, which is, again, hard to see because of the way that this is rendered. Let me shrink this. Yeah, go over here. Cool. On our sigil here, we've got an inner shape and an outer shape. The outer shape has 5 sides. The inner shape has 6 sides. We've done a bunch of math to give us a string with the first number being the inner size. So it has 6 sides, it's a hexagon. The outer shape has 5 sides, it's a pentagon. And then every number pair after that... Oh, hang on, I just spotted something. Please do not advertise anything in chat. I'll have to ban you. Goodbye. Yippee. Each set of numbers after that, so you see 3, 5, 3, 5, 4, 1, 2, 5. Actually, let me change my color. 3, 5, 4, 1, 2, 5. These are all pairs of numbers that describe the connections. And they start at, I believe they start at 0. They should. If not, I'd have to know that they should. I've done this quite a bit. So let's look at the first connection here, which is 3, 5. 3. Actually, wait, which one does... Okay, yes. Sorry, I have to keep looking back at my notes. Three is the index of the outer shape here. So we've got 0, 1, 2, 3. So that's this one. And 3 connects to 5 on the hexagon. 0, 1, 2, 3, 4, 5. That's the connection. The first 2 numbers, 3 and 5, tells us connect 0.5 on the outside shape to 0.3 on the inside shape. The next one is 4, 1. That tells us to connect 0.4, which is this one, to 0.1 on the hexagon. 0, 1, because we start from 0. And then connect 0.2, 0, 1, 2 to 0.5 on the hexagon here, the inner shape. And basically, you can get any 2 combinations of shapes between 3 and 8 sides, and any point can connect to any other point, inner to outer. You can't connect the outside shape to itself. I don't have a way to encode that. So that's what the encoding does. If you want to know how the SVG generation here works, I don't know. I did not write that. I had AI write it at like 4 in the morning. I wouldn't recommend that you do that. You should probably learn how that stuff works, but I just didn't have the brain for it. At some point, I am going to go back through and document this stuff and really look at it. Besides just fixing a few bugs, I didn't have the wherewithal to really fix it. It looks like it's just generating some SVG strings and then displaying it. Or not displaying it, writing it to a file, which then gets displayed by the system. So basically, it's displaying the standard SVG tag you'd get in HTML. Which means that you could theoretically just upload these through HTML to whatever. Obviously, you is rhetorical. I'm not releasing this just yet. This specific sigil system. Okay, let's jump back. Let's jump back to the actual scroll making, what we're here to do today. We've got a scroll. It's got a name, it's got a description, it's got an incantation you read, and you cast fireball, right? Fun stuff. We need the sigil image, and what I do for that is I import it into Illustrator, and I export it as a PNG, and I throw it up on Imgur, as an SVG in my little hidden folder here, and you can open this in a new tab. Right, you can go up to the top here. No, hang on, that's not correct. Oh, it is correct. Open image, a new tab. You can go up here, you copy this link. This is the correct link. If you copy any other link on Imgur, it's not going to work. they need the actual image link where it exists on the server. You go back to Homebrewery, you toss it after the sigil, and then it adds it to the page. And this is ready to go. I think I can print this out without doxing myself. I'm gonna risk it. I'm gonna send it. I'm gonna save it as a PDF, and I'm gonna print it from Adobe, because printing from a browser causes some weird issues. I've also got my print settings here. I'm paper-sized letter because I'm in the US. I've not tested this in A4 because I don't have a way to print on A4 paper. You want to set your margins to none because these get close to the edge, and you want to set your scale to 100 manually. If you don't, things can get thrown off. I will save. Thank God that it not just show my file system. At least I hope it didn't show my file system. I will save this. I will go through my own stuff really quick, and I'm going to print this out. Scroll demo, I think I called it. And then I think that'll round us off for the day. This is going to be a really short stream because I have stuff to do. I was like, what can I throw together for a stream in 30 minutes? And this was about it. Although it did take me like 4 hours last night to actually get the sigil thing working and to find all the fonts and make all the SVGs for the image. Okay. While I send that to my printer, I'm going to posit a question for the audience. You have to, don't pay attention to the printer sounds. Pay attention to my voice. I want to put this stuff up somewhere. I don't know where the best place to do that is. So stat blocks and all this stuff, you need to host them somewhere. Now, I could host them on Homebrewery, but it's not a site that you can just search through really easily. The search is pretty poor. So do you know of a site that's not D&D Beyond? Because I'd prefer to hang on to my intellectual property if I can. Obviously, I can't stop people from stealing, but I don't want D&D Beyond to own it, obviously, right? What am I thinking of? Do you know of a place where you can host it? I guess DM's Guild is an option. I'm interested to see if you can do that for free. Because I know I have a lot of people internationally who watch the stream, and they obviously can't pay. I mean, most folks outside the US can't afford to pay US prices for things. Because like $5 US is some ridiculous amount in a lot of places. Okay, that was the end of that thought. I gotta flip this paper over. I've got to manually flip it for my print on both sides. It's a pain in the ass. But now I've got a functioning, well, not functioning, it's obviously not real magic, but I've got a faux representation of what the spell scroll in my setting might look like. Using some very simple shapes. It was weird. I could not find any simple templates for Homebrewery that were set up like this, which this seems like a very obvious format for spell scrolls. So I had to do it myself, which is often the case when I want something. But anyway, we're here. This exists now, so I can rest easy and go back to what I was doing, which was supposed to be writing stat blocks for the next session. I just realized that I've been prepping a lot for D&D. You know, like way more than most folk. That thought's not going anywhere. I'm trying. My head hurts. It's Friday. Speaking of Friday, I'm gonna go do Friday stuff, which is not be here. I mean,